So as mentioned in the email this video is attached to, a 0.6 kilogram mass is given a quick shove up an inclined plane that is tilted 25 degrees above the horizontal, such that it has an initial speed of 6 meters per second. After it is released, what is the magnitude of the acceleration of the block if the coefficient of kinetic friction between the block and the plane is 0.15? Well, the first thing I did was draw a diagram to kind of illustrate what was going on, and to the top left you can see that the block is on the inclined plane of 25 degrees, and then just next to it I drew a forced body diagram for this problem, which shows the normal force perpendicular to the plane because I have set my x and y axis to be in alignment with the 25 degree incline, and shows a frictional force going in the opposite direction, and shows the mass and gravitational pull going straight down. Now to do this problem, we needed to know the sum of the forces in the x direction are equal to the mass times acceleration in the x direction. The sum of the forces in the y direction are equal to the mass times acceleration in the y direction, which is equal to 0. The sum of the forces in the x direction equal to negative friction force minus mg sine of angle theta is equal to the mass times acceleration in the x direction. And the sum of the forces in the y direction are equal to the normal force minus mg cosine of angle theta is equal to 0. The normal force is equal to mg of cosine angle theta, which is equal to 0. And the frictional force is equal to mu times the normal force, which is equal to mu times mg times cosine of angle theta. And then from here, I was able to solve for the acceleration in the x direction by using the formula negative frictional force minus mg sine of angle theta divided by the mass is equal to negative mu mg times cosine of angle theta minus mg sine of angle theta divided by the mass. And knowing this, I applied the formula for the acceleration in the x direction, which is negative mu times g cosine of angle theta minus g sine of angle theta, and I plugged in my values for that and got 5.483 meters per second squared.